Hello, and this is the virtual field trip tour of Yellowstone National Park by Marcus, me, Maya, and Luca. Background information on Yellowstone. Yellowstone is an area of geologic and natural wildlife. It is 9,000 kilometers squared national park in northern Wyoming, America. It was founded in 1872 and was classified as a UNESCO World Heritage Site in 1972. It has been continually habited by Native Americans for at least 11,000 years and was only started to be explored by the Western world in the 1860s. Vast mountains and rivers allow for numerous species of wildlife to coexist, endangered wildlife, such even as wolves, elks, deers, bears, beavers, and bison, and much more. It's just large animals, and small animals, and insects, fish, etc., etc. Much of the natural beauty is because of the unique geologic activity of the area. And here we've got the Upper Yellowstone Falls, which is an igneous rock, which it was carved by an igneous rock and then a soft rock being eroded away, which is here, and this igneous rock here. Here we have the Morning Glory Pool, which is a very acidic pool. It's very deep, so you can see how deep it goes. The geological significance of Yellowstone. Geology of Yellowstone is very unique, with the caldera of Yellowstone being formed 600,000 years ago during the Pleistocene epoch. It was formed after a supervolcano erupted and emptied its large magma chamber, which collapsed afterwards, as you can see here. This is how it forms. And erosion has occurred it further. It's caused a large variation in the elevation. It allowed for lakes and water to enter underground and form small reservoirs, which then formed many lakes and geysers, famous Yellowstone geysers that you all see, such as Old Faithful, the Castle, which is the one here, many more. In recent years, the eruption rate of some of these geysers is becoming longer and longer between each one. Currently is about 90 minutes for Old Faithful and some different times for others. This is because in recent years there's been more pronounced climate change, which has slowed things down because of a reduction in rainfall and hotter temperatures is reducing the amount of water available to the geysers. This which slows down, and this may slow them down to hours and hours between each eruption. It may completely stop, which has happened in the Middle Ages for Yellowstone during the medieval warm period. The area of Yellowstone also faces many earthquakes, although most of these between 1,000 and 2,000 a year. Although most of these earthquakes have only a magnitude of 3.0 or less. Here again we see the Castle Giza, which is one of the famous ones, not as the most famous, but one of them. And here we see the main things. This was what collapsed, and you can see it folded in on itself and collapsed.
Today I'll be explaining the map that we made. So this is essentially our project. We made an interactive map and a few slides explaining the stops. But on our interactive map, there's these blue icons. So each icon represents a stop. So if you click on the icon, actually, you can see the stop. So this right here is actually the entrance. So this is where we're going to begin our tour. I wrote beginning of tour over here. And this actually will be where we're starting. It's the south entrance of Yellowstone. So the reason why when I drag my cursor over the name, it becomes blue is because this actually brings you to the source of the image if you're curious. And then I'm going to pass it along to Maya to explain Old Faithful and a few other stops.
Our first stop on the tour of Yellowstone is the Old Faithful Geyser. The name Old Faithful stems from the geyser's 90% predictability of the occurrence of the eruptions. The geyser currently erupts about 20 times a day. When the geyser finally erupts, a large, white, fluffy cloud of steam and water can be seen. The eruption can last for a minute and a half to 5 minutes long and can reach from 30.5 to 55 meters in height. The geysers are formed from a hollow tube that runs from the Earth's surface down to the Earth's crust. At the bottom of the tube, closest to the Earth's crust, there's magma, and on top of the magma, there's water. The water flows in through a naturally formed plumbing system formed by fractures in the rock. Then, the water closest to the magma gets super hot and boils, creating steam, and with the increase of heat, the pressure inside the tube also increases, which therefore forces up the water, which then passes through the rhyolite and dissolves the silica, which is eventually then transported to the surface of the geyser, causing additional pressure, which causes constriction at the opening of the geyser. The water that is heated gets pushed up into these holding channels. Then, due to the pressure on top of the channel, the water can't turn into steam. So bubbles form and continue to build until the pressure is great enough underneath the water to force the water to overflow and eject out of the geyser, causing the eruption of water and steam. Then, due to gravity, all the water that was ejected slowly falls back into the tube, and about 30 to 90 minutes later, but currently it is at intervals of about 90 minutes, the whole cycle restarts. Upon arriving at the Grand Prismatic Spring, the beauty of this spring is displayed through the variety of vibrant colors and its large size. The spring has a diameter of 370 meters and a depth of 37 meters, which makes it the third largest spring in the world. The colorful spring contains 87 degrees Celsius water at the center. The temperature at the center is too high for the majority of organisms to survive, which is why the water is blue in the middle. Then, as the water goes further and further away from the center, the water becomes cooler and cooler. There is then a green ring, where the water is at about 74 degrees Celsius. And in this water, cyanococcus are able to live. This cyanobacterium contains chlorophyll, which gives the water the green color. The bacteria that is exposed to the sun causes carotenoids to produce to protect the bacteria from the sun exposure, causing the water to be yellow. Then the orange ring has water that is at 65 degrees Celsius, where the cyanococcus are still present, but chloroflexus is as well. The final outer ring is red, which has water that's at 55 degrees Celsius, where all the bacteria that was previously mentioned can survive, as well as another bacteria called the Deinococcus thermus. Then, the next stop is the Norris Geyser Basin, which is an area known to be the hottest and have the most variation in geothermal features in the whole park. This location claims a spot for the highest temperature ever seen throughout all of Yellowstone's geothermal areas. From a hole drilled 331 meters down, a temperature of 237 degrees Celsius was obtained. Due to the hot water dissolving the silica, parts of the basin will have a more cloudy blue coloring than other geothermal areas. In other parts, an orangish color is present with the help of cyanobacteria. Other areas are green, which comes from the yellow color of the pool lined in sulfur along with the blue light refracted. The Norris Geyser Basin is made up of 3 parts: the Porcelain Basin, the Back Basin, and the 100 Springs Plain. The Porcelain Basin is covered in silica sinter, which is brought to the surface by hot water. This mineral forms a sheet across the area. If a hot spring is covered by the mineral, the built-up water will not be able to escape, so the pressure will force the water to find a weaker area to escape from. The Back Basin is a 2.4 kilometer in circumference wooded area, with a variety of different kinds of geysers, old ones, new ones, colorful ones. The 100 Springs Plain is a very dangerous and acidic flat area, covered in sand but is hollow underneath.
Take it along. Just before I start, I want to show we put a geological map inside this interactive map just to show you guys and explain what kind of rocks is in which section. So on this geological map, it even shows you certain Old Faithful, West Thumb, and it shows you the route too. So I thought it was a good ad. All right, so I'll be explaining I'll be explaining Lower Falls too, but I'll be explaining Grand Canyon of Yellowstone. So it's pretty much 160,000 years old since it was formed. It runs for about 32 kilometers in length, and it reaches a depth of more than 305 meters. So it was caused after a volcanic eruption about 600 years ago, and causing the formation of the caldera, as Marcus explained. I'm not going to explain the caldera again because I think he already did a good job on that. But yeah, so it actually starts from the Lower Falls, and it goes up until the Tower Falls, which is pretty much up here, but I'll explain that later. So yeah, so past and current hydrothermal activity altered and weakened the rhyolite, making the rocks softer. So the Yellowstone River eroded those weakened rocks to deepen and widen the canyon, which is a process that continues today. So the current canyon begins at Lower Falls and ends downstream at Tower Falls, as I said. So over here is Lower Falls. It's 93 meters tall, and it formed because the river flows of volcanic rock more resistant to erosion than the downstream rocks, which are hydrothermally altered. All right, so moving along, right over here, we have Tower Falls. So Tower Falls is 40 meters in height, and it streams down a creek. So it's a plunge waterfall. It is framed by these eroded volcanic pinnacles, and it actually falls directly onto an Eocene conglomerate, which is a volcanic gravel which is easily eroded. So it got its name Towers not because of its height, it's because of these tower-like structures next to it. So they're these tower-like stone pillars, pretty much. So these towers were formed by boulders that shielded underlying conglomerate from erosion. So the most common type of rock found in this area is stream sand, gravel, glacial, and landslide debris, hot spring deposits, and lake beds. The rocks that are at brink of the fall and in the vertical cliff beneath are conglomerates of the Absaroka volcanic rocks and coarse breccias. Yeah. So as you move along, we reach till our final stop over here, Mammoth Hot Springs. So this is a great geological spot because it really demonstrates the deep volcanic forces at work in this park. So the surface demonstrates a naturally heated water system that scientists summarize as being heated from the magmatic system that heats the other thermal areas in the park. So the heated water that travels to the Mammoth Hot Spring is cooled down to about 170 degrees Fahrenheit. The water then rises to the surface, and as it rises, the heat dissolves the limestone. Due to the dissolving of the rock, a white chalky precipice is set on the surface of the spring. Thus, the pressure caused by rising hot water forces carbon dioxide to escape, and the bicarbonate in the water continues to break down into more carbon dioxide and carbonate. Then the carbonate reacts with the calcium, which forms calcium carbonate, the white substance, which forms the travertine. Yep. All right. So we finally reached the end of our tour. It ends right over here. So this is the south entrance of Yellowstone. Just a nice pillar. And yeah, I hope you guys enjoyed. Thank you very much.